Okay, sure. So, hi everyone. So, in the last session, I actually conducted a session on how we actually like deploy apps using fast APIs and the whole the bird's eye view of the scenario on how to actually like manage and also like practice the best practices on the real world ML applications. So today, I will try to provide a hands-on on how to actually like create a basic fast API app and like use Docker to actually like package it and like use for the production. And also the whole workflow of this session will be like we will start defining the problem, and mainly due to the time constraint, as we have 1 hour of timing, and creating a whole fast API like project is like will is very much time consuming. So we will just keep it short. I have already like try to code up the whole project and also try to running the things. All I will try to do is just go in the most important part of the lines, and I mean you all are like free to ask any sort of questions, and we will just go work through of all the code, and based on it we will be like getting some sort of insights. So yeah, let's get started. I am sharing my screen. um yeah, I hope you can see that is the blackboard, right? Is it visible? Hello?
Yeah, it's visible.
Okay. Awesome. So we all know that it actually all starts with a business problem, right? So I mean, I will just go for like 1 to 2 minutes about the whole life cycle once again. So it's like we will be having a business problem. So suppose in our case, what's the business problem is? Like let us assume for now in this session, what we are actually trying to do is we are given some like patients some sort of information regarding their health, and using those information we are going to try to predict like whether the patient has like potential heart disease or not in the future. So that's the whole business problem, and why and how we can say like it's the business problem, because in the long term what we can see is like we can create a whole like ecosystem or an apps around it which is related to the AI in healthcare, which actually tells like all the different like predictions regarding some person's health report. So this application of the that we are building right now maybe is the very small part of the whole product, which is like only we will be having some tabular informations of the like the patients like the reports, and using those what we will try to predict is whether the patient will have some sort of potential heart disease or not. And also just to keep in mind, to keep things simple, and like the data that we are using is sort of dummy and is not very much related to the real world. And also if we go through it, then there are like a lot of steps involved in the actual machine learning paradigm, where after getting the business problem, there will be actually like a whole team of data scientists and ML engineer, data engineer, and everyone just like sort of brainstorm. And mainly the during the very first time, the main part is only about the one who is very much having an expertise in the field, as well as the data scientist and the data engineer, where we will be having like data sourcing, like we are like gathering the data and the ETL. And next, once we have some sort of data, the data scientist comes in the picture, where they actually take the data and try to have some valuable insights on each and every like the data they used to have. And once I am having all of the like the different insights, now I am actually ready to have some lot of experiments with the model in order to get some sort of predictions. And in order to do that, before getting my data to the model, I have to prepare the data in such a way that it is like very much optimized for the model training and the prediction or inference. So for that, I will actually go for the data preparation. And once data preparation is done, then I will actually train the model. And once my training part is done, then I will deploy and monitor my model. So what we are going to do is for today's session, and also it's not only on, so this is actually a cycle where once, so the whole thing doesn't complete once we deploy the model. Like there will be a lot, like the model that we have actually trained during the time of our training will not guarantee that it will actually work during the time when we have deployed the model and it comes faces the actual real world challenges of data with completely different distributions of the training models. So when we see that there is a decay in the performance, then we go once over again on the same step and try to actually reiterate on the same until and like unless we the model or the whole thing actually have some sort of stable, like we actually faces some sort of equilibrium in terms of stability in performance. So yeah, that's the whole scenario. And today we are actually sort of like skipping this part, and we are gonna like go over through this very fast. Like we will just do some simple ETA, some sort of basic like transformations in the data, like some sort of scaling, and we'll try to train our basic model. And here is what we will try to do is we will try to create our inference engine, and it simply means like we will try to have some sort of functions which will actually try to do some sort of inference. And once that is done, then we will try to use our app or use our machine learning model to deploy it as an API. And what an API is, if we go like in very simple terms, then all I have to do is like there will be my end user, or there can be anyone who will actually give some request over web, some sort of HTTP request, and there will be my server where my server will have this like all sorts of my ML machine learning codes and my machine learning like model. And in the request, what the request will contain in general, what a request contains is like the headers, where the headers actually contains the authorizations information, etc., etc., which actually belongs to the user identity, and also the body of the request, which actually contains like what sort of information it has. And in this terms, my request will be having some sort of features. For example, what was my so let's just like come towards how my actually machine learning like the data looks like. So we will be having the patient's age, sex, the CP, and the other sort of features. So here my request will be having all those features around there, and this will be my sort of request with some headers, and this will go to the server. Server will try to actually see, okay, my user is authorized and here are my features. I will use those features and try to make some sort of a data which is actually compatible with the model, and it will give to the model. Model will do some sort of inferencing, and they say, and the inferencing, once it gets in like the inferencing is done, it will try to provide some sort of response like, okay, this is my request, and I will try to provide a responses this like based on the data that you have provided. The prediction was like, okay, there might be very less chance of heart attack, and the model has predicted this prediction with some sort of confidence, right? So there will be the confidence of the model like, okay, my model is about 70% or 80% confident, and that is actually the class probability, like that there would be this type of predictions. And also there will be response like status, like whether the response was done and like completed successfully or not, which will be like 200 in this case, which is my response status or response code. So yeah, this is how an API generally works. There are several ways, and in specifically, this is how a REST API works. And user will actually try to do, and in case of this, the type of request the user will actually put is some sort of a post request, where user is actually posting with some sort of its data, right? Okay, so that's the whole like how we are actually gonna we are gonna do. And also let us actually like jump how the architecture would look like. But before that, I would actually let's just like go through the very first steps. So here is like our how we are actually gonna like do today's session is like there is like okay, let's just come to the code directly. So if we see, I am actually closing each and every code, and do not like get afraid or frightened by seeing this large codes. These are like, it's not very much like long, and it's like very easy to understand. I will try to go through each and every line, but at first like try to see how the folder structure is done. This is not this is not the absolute like the standards on how the main machine learning projects are done, but yeah, this is, we can say that this is some sort of a best practices when we are starting out on creating like fast API projects, where we will be having this app. This app will actually have all the things which are related to directly to the fast APIs, where I will be having, where my each and every endpoints will be there, my the data models will be there. And what are data models? Data models are nothing but the how my like I am putting some sort of request in sort of in terms of some JSON format, right? In general it is like in JSON formats, and in JSON then will be like multiple sort of data types. So in order to capture that, and in order to have some sort of a particular like structuring, we use the data models. We also have the exceptions that which will actually handle some sort of exceptions. The main.py is actually the our main fast API app, and some sort of internal configurations which are actually used when we are actually either in the dev environment, and it changes when we actually go to the prod. So I will go through that, don't worry. Next, we are having the checkpoints. This is the model checkpoint. That is the model which has been saved. This is our data, and also let's just go through the models, which is our like the base model, which is our PyTorch model. And next, we have our notebook. And in the notebook, suppose, so now we are actually in the first step where we are trying to have some sort of EDA on the data and how the data looks like, and we are like trying to do some sort of experiments, like imagine like that. So I will not go through the notebook specifically because this is not in the scope of today's session. However, I will like also try to push all the codes to GitHub and try to put this session on YouTube, and also provide all the resources along with all the notebooks and all the changes in the code, and you can actually check out and go learn more on that. So in short, what I've done here is like loaded the data. So I've checked whether there is any sort of NaN values, and here it is not. Try to have some basic EDA, although EDA is some sort of time taking process. Although just like saw how the distribution looks like, and then we did some more pre-processing of the like categorical and the numerical variables, and try to do some sort of one-hot encoding. I hope and I assume that you guys are familiar with these terms. Then what we do is the train test splitting in order to see how our model works on the that is the in case of validation. And we are trying to create a basic model, classification model, and then we trained our model and we saw our accuracy, and this is the accuracy for the validation set. And as far as we see, our model is perfect, like working really well. Yeah, and I mean not really very well, but yeah, it's a good starting point, right? And we are not very much focused on creating the model, at least in this session. So we can actually work over that. And also based on the data we have, we do not need to create a PyTorch model, I mean, or a neural network in this case. Is just for this session is we actually created a machine learning like a neural network, because I actually wanted to show like how to integrate like integrate the complex like styling like using PyTorch and FastAPI. Otherwise, sklearns works very well for this type of data, but just for the case of the session, I've just used PyTorch intentionally. So, so next, actually, what we try to do is this model inference, and this part is actually very important, right? Because if you see now, this is how our parameters, that is the request will or the request body will look like, right? Like this will our user or in intermediate, this will be my request body will be which will be having this age, sex, chest pain type, resting blood pressure, cholesterol, etc., etc., which will be having some sort of values. And based on the values, I will try to pre-process this request body in such a way that I finally come out with a torch.tensor format so that I can feed my model, right? So what we do here is actually we do some sort of categorical encoding, and then like we actually convert the boolean values to integer values. And similarly, like all the boolean values and all the ones which has to be categorically encoded has been done using all of these function. I hope these are like the simple functions, although if you have any sort of doubts, then we can take in the Q&A. And once we are like into it, then we actually collect we finally return our tensor format, and we actually predict using our existing model. And once our prediction is done, then what we try to do is like we try to get the class and the class probability. And finally, what we try to do is like save our model, and we save our model as well as we also save our scalar, which is the standard scalar. In this case, I've used robust scalar, which is the part of this scikit-learn. But the thing is like we actually have to like save the scalar, also the scalar object, because that is important in order to like when we will having our test data, then the test data will not be like each and every values will not be scaled or normalized or standardized. So in that case, we need our like standard scalar or whatever scalar that we are using, so that we can like we can normalize or standardize our data in order to having the correct distribution. So yes, that was the part of like creating the machine learning model, experimenting with it, try to see the results, and assuming right now that okay, I have got a very good baselines. So let's just like try to deploy the baseline model by like creating some sort of version on it, and try to like try to actually put it into the like production and try to see how our model actually reacts based on the customer's like data, which is in the real world scenario. So in order to do that, let's just like jump to the main code, which is our fast API code. So the very first important thing is that before that, let me know you have any sort of questions. If the questions are big enough, then I will try to cover it like in the later part of the tutorial. And if it is like uh, directly answerable, then I will just answer right now. So any questions till now? I assume that you do not have any sort of questions. So I guess I can move forward. Or any questions? Okay, let's move forward then. So now the very first thing is we will be having the app directory, which is actually mainly related to the fast API. And here, uh, the very first thing is like let's just like go through the config file. So very like some part of the project, like this whole like project has been inspired with an awesome blog which I have actually like learned from and studied, and I will actually put all the resources like just after these sessions in the Slack also, as well as when we will be uploading to YouTube. So the very first thing is like when we are actually deploying our like any sort of apps before going to production, we need to like be ensured that this app is actually very much working well. And for like so before that, we actually have different sort of environment. We have a production environment, we have a development environment, and we might have an intermediate environment known as the staging environment, where we before going to production, we try to actually have the debugging mode on, so that if the model actually faces any sort of error during the course, then we can actually try to backtrack on the error and try to actually solve it. So that's why we have this environment config, where for different types of environment, our configuration will be acting accordingly. So suppose in the production environment, we would not actually try to like provide any sort of like so in the production environment, if there is any sort of faults, then all we will be seeing is that the model has provided a 404 error, right? Which is like very much prevalent in the real world. But in the case of like the during the time of development or the staging environment, we do not put anything we do not put directly the 404. Instead, we also put like what sort of error we are actually getting. So that's all about the environment config. The global configs actually are like where the model path is, where my scalar, which is my standard scalar here, is located, and which is actually located in my checkpoints. Although in some of the scenario, there are more better best practices where we actually pull our model from some any sort of registries. So that's another scenario. But for now, let's in order to keep things simple, what we are trying to do is like we are having a checkpoint folder where we are like having the models inside that and the scalar files, and also and finally we are having some sort of config, right? So if I run the config, then you will be seeing like if I just go to the app, and if I run the config, then you will be seeing all of this. And actually we will use this config on our like fast API apps, or when we are actually building the fast API applications. Next, we
Hi,
are
Anindya,
coming.
I have one question. Can I ask now or should I ask later?
Just ask right now, and if it's like that now question like answerable right now, then yeah, I will
Yeah,
definitely answer
so,
or
so
sit for later.
I think what was there in your config file was that in the production environment, the debug mode was turned off. So in
Hmm.
case there is some user which faces an issue in production, how do we look at the probable problems for that specific user without the debug log?
Now for that we have like separate monitoring services actually turned on, which actually sees on the other side like what are the like potential problems. But in this case, now the thing is like when the debug mode is off, it is also like a very important part actually for the reason which is actually done is actually not to show any sort of like potential sort of secrets or anything else if the debug mode is turned on sometimes, because it sometimes reveals that otherwise there are like other like the monitoring services which are actually like integrated with our like the applications, so that that can be treated as a different sort of problem. Although I will be honest here, I didn't like went through that part that the question you asked. It's an awesome question, and I guess I would like to like learn more on that and then try to specifically answer after this session.
No
Yes.
worries. Yeah, thanks. I think yeah, the point you made about linking with another telemetry service makes a lot of sense. Yeah, thank you.
Yes. Yeah, sure. So yeah, let's go forward. Now we will be having the exceptions.py. Now in the exceptions.py is like when we are having the debugment on, right? Then we might have like different types of exceptions. One type of exceptions is right, like suppose I have been having like suppose so I will the very so here one thing is actually to mention. The very first thing is like the files that the course which has been written in the exceptions.py is something which might not change when we are actually starting out, because like there are like 3 to 4 different types of exceptions, and those are like handled in similar manner in whatever types of like applications you are making. And the very first type of exception is like suppose my request, like suppose let's just like have this scenario, like I'm having a age, I'm having like for example how my blood pressure is, and also I am having this boolean value, like whether like suppose this is my integer value, this is a float value, and also suppose like I am having a boolean value like whether I have consulted to doctor or not, like consulted consulted, yeah, suppose this is a boolean value. Now, suppose I'm using the API, and when I'm trying to using the API, then my request has the type which is actually mentioned in my request body doesn't match when I am trying to put the request, right? So it might be like I have put like BP as I mean I might thought that okay, my blood pressure, maybe it was saying about whether I have high blood pressure or not. So I have like put a boolean value, and in that case it's an exception, right? Because boolean like our code has been like maintained in such a format that in terms of boolean value it cannot like process it, right? So in that case an exception will be occurred, and these type of exceptions are the type of exceptions which actually occurs in the data models. Now what are actually data models? So suppose this is my request body, right? And in the request body I am having like different sort of elements in the request bodies, which is like age with a different type, the blood pressure different type, consulted or not, which is a different type. So what a data model is that data model actually structures all of these like elements in a format such that this can be actually integrated, or this can be used during the time when we are actually putting a request in maintaining the same sort of format of how a general like web requests are made. So when we will be having a different type of format or exceptions in those format, then we might have like generate some sort of exceptions. And in this case these exceptions are actually the like these are generally the response which are like in the data models. Another type of exceptions which actually occurs is might be like there might be the internal Python exceptions, right? Like for example, anything could be happening, like let us assume the case somehow or in some manner my one of the functions might be wrong, and I have not like It's not something like, let's just assume for now that I have some internal Python errors. I mean, we always have some sort of Python like bugs, right? Which, and in that case we'll be generating a different type of format, although during the time of productions all of those are like maintained as a 404 error. But during the time of debugging we try to see like, okay, these are the type of exceptions for different types of scenarios that we are actually having. So the exception files actually like tries to handle all of those. Next we will be having our inference folder, file. So the inference file is something very much important, and actually we want to, at the end of the day, our main like motive is to keep everything modular, things reproducible, as well as things are more extensible enough, right? So what I could do is like, I could actually like do this inference inside my like FastAPI applications, but that would not make sense, because if I need to do any sort of changes inside the inference, then it's better to do it separately than directly inside the like the main the application code, right? So the main inference is this class is actually like acting like as an inference engine, where like what we are trying to have is like, it's the same thing like as I mentioned before in the Jupyter notebook. And that's the reason why I have actually done this before, is like we will be having the parameters, and the parameter is nothing but the request body. And once we will be having this request body, then the in our inference engine, which is actually mentioned in the that is the different like in our Python file, is a bit different, but the logic or the workflow is similar. And and that is actually that here we are directly having some sort of a dictionary, but here what we will be trying to do is like we will be having the request body, and this request body is actually a pydantic model, that is the pydantic based model. And in the form of the that is the actually the request body are some sort of data models. And here what we try to do is like we are actually applying the same sort of like the functionalities and the same sort of logics that we have mentioned before. And so, and here the very first thing is like we actually do some sort of pre-processing on the request body that we are actually getting, and the one that I've actually showed you in the Jupyter notebook. And secondly, so as you can see that this is the same logic that I've written earlier. And next I will be having the main inference like code, which is this simple predict function. And that it will be like, first I will be having this request body in terms of our dictionary format, and then I will pre-process this request in order to get our tensor format, and I will do my predictions using my existing model, which is like my pre-trained model. And I will be having my prediction class, or and the prediction probability, which is the confidence. And I will be returning this like in terms of a dictionary, so that I can actually like further like put this in the form of our JSON response. As we can see, as I guess we are very much familiar, right? We have all used APIs, and in APIs, in most of the cases when we use REST APIs, then when we put any sort of post request or any sort of request, then we get a JSON like response as an like a response, right? Which is a standard format. So we are trying to do the same thing here. Now moving forward, which is our main thing here. Now let's like go towards the schemas.py. And as I mentioned before, now these are the data models. Now you can like so in the data models, if you see, then we are having, so if you have actually like went have any sort of prior experience with Django, then it is like a similar sort of things where we actually try to have or try to initialize or instantiate or try to like provide or I mean design our data which is actually incoming in some sort of a format, right? Where each and every like the elements of our data will be having some sort of like values, will having some sort of range of values, and what are the description of those values. So that will actually try to maintain all of those. And here we are and Pydantic actually helps in order to do in order to actually accomplish all of those. And there the very first thing is actually we will be having our inference input. And this inference input is the one which we actually put in the request body. And in the request body what we try to do is like as I mentioned, right? Like these are the request body, which is the age, sex, the chest pain type, the resting blood pressures, cholesterol, and etc etc, all of these things. So here when will be so let's just like in order to make you understand more, because I am having a hunch that there might be some sort of like confusion in it. So let's just like go towards a curl request, and that would actually make the work more easier. I guess you are all familiar with a curl request, right? Like we actually test APIs or get the direct responses from the any sort of REST APIs using curl. We can also use like the requests library in order to get some sort of request. But now see, like I am using a curl request in order to get some like response, and I'm using a post request where I'm trying to give these sort of parameters, which are my age and the other sort of like parameters which will be used as features. Now when we are putting this, then these are actually attached with my request, right? And that request with the request header and the request body, and this is actually attached to the body. And in order to get these like request body and actually put it into the frame or put it into the format of the one, such that we can actually fetch from the request body and try to get our corresponding like all the parameters and then transform it into the tensors. We use the pydantic data models, and for that we will be having different types of data models. That could be like there will be an input data model, which is my how when we are actually putting the request in request body, we'll be having a response model. That is because at the end, if you see, then all we are trying to do is try to put the request and and the response in terms of some sort of JSON or dictionary format, right? So actually it will be a JSON format. So the response model or the response body will also be having a similar type of formats. So if you see, then this is my response body, and in the response body there will be like the whether there is any sort of error or not, what was my prediction, and what was the confidence. And there will be also an inner response will be having like the what was the error, what was the error message. And if we go over the debug in the debugging mode, then there will be this traceback, which actually like after each and every Python's internal error, we actually see like there is some sort of like traceback error. So we will be also able to see those. So yeah, that's all about it. And if you also, another thing to mention, when we actually sort of instantiate all of these like data models, then we have to actually get like we have to actually ensure like what type of like the elements will have the data types in example of it, and what the data is actually containing. For example, there is this age is in the form of integer, and it will be of like, for example, it will be having this title of what was the age of the person and this example. And also this field with this triple dot actually means that we can actually put any sort of other parameters on it which are additional, which is so that we do not constrain on any like these you can actually think of it as some sort of default parameterizations, and we do not like constrain it by putting any sort of like other constraints or conditionals. So yeah, that's about like how the data models are actually, how we use data models, and how the data models actually are used during the time of when we actually get the uh, like when we actually put the requests in the request body. And this is essentially actually works as a data class. So when we actually try to get our request body as a response, then what we will try to do is like, so suppose how fast API works is like, will be when we actually try to have some sort of endpoint, like I'm having a post request and I have a function which will be having like, just one sec, I will be having a post request, and this post request will be having a function where I will be having the request, like the that is my main the request header or the request in general, and my request body. And how I will be accessing it is like, I will be having this age is equals to this body dot age, and this will actually return me the actual age or that I've actually put inside the body of the my that is my request model in my request API request. And similarly, I will be having, for example, like the BP is equals to body dot BP. So it's essentially actually working like a Python's data class. And now, if we go to the main thing, which is our main.py, then now, like now for now, what are the steps that we have done? The steps that we have actually done is right now we have actually have some sort of basic configuration so that we can actually configure it based on the type of environment we are working on. We have also like maintained the also written the exceptions, the required exceptions that needs to be handled when we are trying to have these API requests. And we have also like mentioned our inference code, and I hope the inference code is not very much hard, because all it's just doing is some sort of pre-processing and doing a model prediction. And if you are a bit very much like less familiar with PyTorch, then also I hope that on the basis of intuition, you can understand it more. I could have given more time, but since I am only having like 15 to 20 minutes more, and we have to cover the main like fast API application and how to use Docker to like deploy it. So yeah, I will try to go forward. So now let's just come. So after like finishing everything, we have like also maintained our schema, our inference, our exceptions, configurations. We have also defined our model. Model is saved. Everything is like working. Now the only thing is like use the different like you initialize different endpoints, and based on the different endpoints, we'll be having different functions. So if I try to explain it more, then like how the routers actually works, right, in a website. Like I will be having like suppose like google.com maybe, or any sort of like any sort of website, right, like some sort of website.com. Let's assume, because I'm not getting any sort of website name right now. And now when we put any slash, then this is actually in my home, or it's actually in my root of the website. The way how it works is similar to the app or in directory structures. Like when we actually go to some another router, or we actually route to some another endpoint, for example, like merchandise, then what we see is like we are actually redirected to a like for example the merchandise page. Or for example, if we have the same, we actually have this about section, we might have a carrier sections, right? You have all seen it. And similarly in APIs also, in REST APIs also, we can have multiple endpoints. So at the end, these are my endpoints of my actual like the main uh that is the link here. So the thing is like, for example, I'm having this API of suppose my fast API. I've hosted it, fast API slash suppose predict. So what it will try to do is like predict, and this will be having my response, that is my request header as well as my request body here. And what is now essentially, this is actually working as a curl request. This is actually working as my potential request, and you can actually see it here. Like I'm having this post method to this, that is my this web, and that is my this link, which is my local host here. And then I'm having this API slash v1 slash predict, which is actually saying like, okay, I'm having this endpoint of API under inside that. I'm having this version because there might be different models with different ways it works. So maybe I've initialized different versions of the models with different endpoints. So suppose I'm having in version 1, the model is the my machine learning model is different with the one if I have initialized version 2. So that's the main motive why I have like mentioned this v1. And then we have this predict endpoint, and this predict endpoint is actually saying like, okay, I will be having once I mention this predict endpoint, which means I have to use the prediction function, which is the inference function. So now if I do the inferencing on what I will be doing the inferencing, then I will be actually going to the request like body, and this request body will be having like this all of these like informations. And once I'm having all of those informations, then I will be having some sort of response, which is something like this. And as I mentioned, if you see the response body in the schemas, then if you see this thing, you will be seeing that there is this error message with like whether there is any sort of error or not. This message, which means sorry, this error, the prediction, which is the what was the prediction and the confidence of the prediction. And if you see, then I am having the same sort of results in the similar sort of formats in a JSON, in a potential JSON format, right? So that's how the endpoint works. Even if we go directly towards the app, which is like if I run the app right now, then you can actually see the thing. 1 second. Yeah, the app is already running. Or let's just like run it once again. So if I like, for example, use the curl request right now, then it will actually see that it fails to connect, right? Because I do not have connection with my app. So now what I will try to do is I will run my app, just one sec, and yes, app is running. I guess there is some sort of problem. Just one sec. Let me run the app, then I can give you a better picture. So I do mention my environment variable, Python path, application slash main.py. Okay, and here we go. So if you see right now, I have, so this is my actually the root directory, and here nothing is mentioned. So the right now my endpoint is something like this, which is this single slash. And if you give this single slash, then I will be having this default directory. This is, and that's why we are saying that this is a root directory. Now here for this like application, I have like two endpoints. The very first endpoint is like the about section, like what was the app about, and the second thing is about the predictions. So if I go to the about section right now, then you can see that I'm having all of these like about informations, and how all of these things are working. Then let's just like dive directly to the code. And this is the and also FastAPI has a very beautiful thing of actually generating the documentations automatically, and you can actually try and test all of those like requests and see whether my responses are actually generating or not. So it actually works like the post like a postman also. So yeah, it's actually very handy and it's super cool. So you should actually also try it. And if you see, so let's just like go directly to our main app. We are importing a bunch of things. So the very first thing is like we are importing like the UVCon. UVCon is actually helps and acts like a as a server code in order to like run the first API applications. We are importing fast APIs. We are also importing the inference, like the inference class from the inference. We are importing our model.baseline model, which is our main PyTorch model from this models folder. We are also importing the from the schemas as the different type of data models, and we are having this inference data model, the error response model, the inference response model, and the different type of exceptions. Here we actually initialize our main application, which is our first API application. There are a lot of things that you can actually mention. There are like description to the app, and a lot, and where should be my static files will be, and the other things. There are my exception handlers, which will be actually help my app to add the all the exceptions that I have actually mentioned and initialized. Next, the very first thing is like suppose this is very much important. Like before starting our application, we do not want our model like for each and every request we get, and for each and every request, whatever features that we are getting from that request, we do not want that our model will every time get initialized from the like the .pth file or .pt file, and then it will try to run the inference, right? Because that is super time consuming. Like suppose you are pulling it from like some sort of registry like from the cloud, then it will try to download it every time. So in order to, so before doing any sort of predictions, I will try to have like sometimes on my hand, so that it will try to set up everything. And here like I'm trying to setting up my model. So here so that my models is now like actually stateful. So it's like right for now, for each and every request, my model state is something like actually like not lost. It can, and it will not have to like load every time once I'm actually putting the request, right? So for that, I'm actually like preserving or like preserving the state of the model using directly directly on like before the app actually starts. I first like initialize the model and also load my model using the .pth files. And then what I try to do is like I package, or I like tell my fast API is like, okay, just remember my like the my model and my scalar values, so that I can use it every time I am having the request without loading it. So that actually keeps in the memory of it. You can like think something like that. And then comes like our different sort of endpoints. So these are my endpoints. When I'm having this slash like directory, then I'm in the root directory. So here I'm saying like, hello everyone, welcome to the FastAPI tutorial. Next, I'm having this post that is endpoint, and in the post endpoint, I'm having this predict functionality, and in the predict functionality, I will be my input model will be, and so the response that I will be having will be in the format of my inference response, which is mentioned in the schemas as mentioned before, and and that will actually initialize a predict function. So before moving to that, let's just like get to the about function. And in the about function, as you've like, I have already like went through the about function, as by going through the in the about endpoint, you have seen like there were like some sort of informations generated, right? So these were the informations when we actually go to the about endpoint, and it's just a simple get request. In the get request, the user, from the user side, we do not try to put any sort of additional information. We try to get the only the response from the APIs. And you can like think of it as like a get request, as you are pulling anything from any database, right? You're just getting something from the database, the data of some user. And finally, the predict method, and the predict method is the one that we will be using in different sort of requests. And here what we actually see is like we will be first having this predict method, where we'll be having our request, and the body will be in the format of our inference input. And then we will be having our request parameters. And as I've said, like this is actually the, once we are getting the request body, then it actually is some sort of like acting like some sort of a data class, and we are actually accessing each of the elements by pointing out the element that we want. And we have like mentioned in the format, which is very much similar to something like this. And once we are getting it, then I'm getting the response from the app.inference.predict. So what I've tried to do here is like, as mentioned before, like before the application mainly starts, I want to have my application's models and scalar value, everything loaded at once, so that I can like use it anytime I want without like losing the state. So before, so as I'm so before so initially, actually, that the very first moment I've initialized my application using the app.inference is equals to instantiating my inference, that is the class with this, with the model and the, that is scalar values. And now I can actually use my model and my scalar values anytime I want. And in order to, if you are like thinking that you're getting confused in some sort of parts, then I will like surely like provide the resources that I've actually followed in order to understand it. And so just pardon me, because we are having some sort of like time constraints, so I have to actually follow up in some in a good speed. So yeah, so the thing is like, once we are so we are getting the response using our predict functions. And finally we are trying to provide our response in a term of a dictionary, which will be, and that dictionary will be actually be converted to this response model, which is the inference response model. And this has been done by inside the fast API in the backend. And that's actually make it super cool, because we do not have to work on the stuff which are not very much required, right? So so that's the main thing. And if we try to actually see how that has been working, then let's just like directly run to the code. And that is the docs. And in the docs, if you see, then this is my predict functionality. And in the predict, it has been already mentioned like how so this is an example value. And how I'm getting this example value, if you see in the schema.py, then I have like put everything in the example, like what could be the possible examples, so that user can actually test with some sort of a default value. So I have some sort of default value here. And the responses that I will be actually getting is, if it's a 200 response, then I will be getting this sort of response, that is the error will be false, some sort of predictions. It's not obvious that the person will obviously has heart attack, it's just an example. And if I'm having some different sort of response, then I will be having this traceback response and other sort of internal error response. And these responses are has been like added using this exceptions.py, which we have actually mentioned before. So those are actually handling all of those error responses. So if you try to actually, and you can also like try it out, right? You can try it in using this interactive docs, and that's why it actually makes it interactive. If you use only these like default formats, you can also change it right away. So I can like change it to 156 or like 100 and just one sec. Yeah, 103. And I mean, this can be 0, anything, and let's just like have any sort of dummy value and try to execute it. And once we execute it, we have this like default value. We are having this response value, and this in this case this is 200, which is fine. We are having like a good status code. I mean, there are no errors, and we are having this error response, we are having this response generated. and and that's how the response should actually look like. If you see, like, this was how my responses should look like, and that's how I'm actually getting the response, right? And the confidence is actually 1. And here it actually means that my model is having 100% of confidence, but in real life it always doesn't actually work something like that. But yeah, that's how my app is working. And that's how you actually make different types of like a simple fast API applications. And now if I want to like use this API application, and like suppose each and everything is working, and now I want to package each and like all of these stuff and try to put it in a container so that I can run it independently whenever I want, and also integrate it with different sort of functionalities. Then all I have to do is try to create a simple Docker file, and that Docker file is something like this. If you have went through my previous like the if you have like went through my for example the previous sort of my tutorial, then you have already known like how the Docker file is working and how the Docker images are working in layers. So these are like each and every layers, like from I'm actually pulling it from my latest Ubuntu's Docker image and also the Python's image. And once all of those are installed, then I'm running some sort of utilities like some simple add packages. I'm installing the torch, and also I'm installing like the requirements.txt, that all of my required packages. And then what I'm trying to do is right now think of like I'm having right now think that whenever my container will be initialized, then my container will be actually something in actually that will be in something in this type of format, which is in my home directory, and there is like nothing is there. So right now what I have to try to do is I will have to copy my models or any sort of files or any sort of folders from my host or my that is my host to the potential container that will be actually made when we are actually running the image. So when my container would be built, then I will be having my models, my applications, that is this application whole directory, my models directory, and the checkpoints directory added inside the Docker container. So that's the reason why we are using this. And next, what we are trying to do is like we are having some sort of using an environment variable, and also we are exposing our Docker to another like port of 8900. And this has actually been done because if you have remembered or if you have followed the any of my previous like tutorials or any other tutorials, then you know that Docker are when Docker containers are isolated in nature, right? They do not communicate with the host if you do not have any bridge, if or if you do not like maintain or like use any sort of bridge that actually connects it. So this expose actually does is like so the on the port that my Docker application will be running using 8900 port, when I just go to the local host and try to use or try to run our Docker using that, then what we will be actually seeing is like that now if we do that, then all of the requests that we are actually like the user is actually giving to the Docker or giving to the server, inside the server my Docker container is running, and inside that Docker, so the all the requests which are actually going to these servers now can actually go to the Docker. And Docker can actually like Docker container, here is my FastAPI applications, and all the response that I'm actually getting, I can from the Docker container to my main servers to my user, I can actually provide it. So that's the reason why we actually use expose. And then my I will be having this CMD, which is this command, and that's actually the main command line that is the code or the command that we will be running every time we will be actually running our Docker, or that is the trigger our Docker container or trigger our build from our Docker image. And that's like whenever our Docker container will start, it will start our this main.py, and this main.py is nothing but our main fast API applications, right? And 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 once that's done, then this will actually open open something like this will where at first it will like load each and everything, and now our Docker container is ready in order to get into productions. And once this Docker container is ready, then we can actually put it like in anywhere. Like for example, we can use Google Cloud, like we can use actually Google Cloud to use the app images in order to register our like container, register our image. And what it will done is like now Google's inside the Google Cloud, it will do the same thing. It will like spin up the container, and now using any and it will and also the everything would be exposed. I will be getting that is a link, and using that, what I will, if I put any sort of request, then easily I can get my response from that deployed model. And that's how we actually deploy the Docker images and potentially the containers. And also for some extra and that's and how we actually build the Docker. So I'm having right now this
Just one
Docker.
thing, sorry, we're running a little
Yes,
beyond
yes,
time.
yes.
If you could just run.
Uh, yeah, yeah. We are already wrapped up. It's just one or two things to be mentioned. So that now the very simple thing is like how to build a Docker image. So if it's a very simple thing, like we use this Docker build, and we use this compress in order to compress all of these files in order to make it like space optimized. And then we actually put a tag. Like it's mainly done in order to create different versions of the images in order to, like for example, for the development we have different version, for the production we have different versions. So so these tags actually helps us to like maintain and version and maintain and helps in versioning and in the version control. And if you like run it, then just one sec, this will, yeah, just one second. We are, if I run the Docker image, let's see, and if you see, everything has been built. And now if you see that the Docker image has been building like super fast for now, and that's because the reason, if you remember, then Docker actually does everything in layers. And once each layer is built, if we like put any sort of like new changes on it, then till that layer which has been already been built, there will be like no changes. So that will be like kept as it is. And the only that part of the Docker image will be built where there is like this changes inside a Docker file. And now my Docker images has been built, and if you now check my existing images, then you can see like ML session 1 has been like already there. And how to like run it, we actually do is like I copy this ML session, and I do this simply like Docker run, and what's the Docker image name and the tag of the image. Then you can see that my apps like is starting to run. The application startup is complete, and now I can actually access it to this port, and this port will open the same, like it will actually expose it based on the port that we have actually mentioned it. And once done, then we can like use the same very same thing like using the Docker container. And now we are actually ready to register this Docker image to any sort of like image registries. So that's a very brief about how we actually like create once this ML application like ML that is model development is done and all sorts of experiment is done. This is some of the very first step that we as a practitioner can actually like have in order when we are actually starting out like creating a fast API models using Docker, and then using some sort of like image registries to register those images and then run it accordingly. And in some of the other follow-up tutorials, we can also I would also like to go with Kubernetes, like K's, like how to orchestrate like different sort of images in order to create a whole applications and like try to have this cloud native machine learning applications or microservices. But yeah, let's keep it for some another time. I hope like this was quite informative, and we could have like discussed more of it, but for time constraint we are not. And yeah, so that's all about it. Thank you very much.